Machine learning, in simple terms, is a way to make computers learn from examples instead of following handwritten rules. In traditional programming, you do three things. You take input data, you write explicit rules, and the computer follows those rules to produce an output. For example, with email spam, you might write rules like, if the subject line has certain words and too many links, mark it as spam. This works when the rules are clear and don't change much. Machine learning flips that process. You still give the computer input, like emails, but instead of rules, you give it lots of examples with correct answers. Spam, not spam. From those examples, the computer figures out its own internal rules. The result is a trained model that can label new emails it has never seen before. That word model is important. A model is simply a function that takes an input and produces an output. Inside the model are numbers that control its behavior. Training means adjusting those numbers so the model makes fewer mistakes on the examples you gave it. The learning process follows a clear loop. First, collect data that represents the real problem. Second, turn that data into numbers the computer can work with. Third, choose a type of model. Fourth, measure how wrong the model's predictions are. Fifth, adjust the model to reduce those errors. This repeats many times. Finally, you test the model on new data to see if it generalizes, meaning it works beyond what it memorized. There are different types of machine learning depending on what information you have. In supervised learning, you have inputs and correct answers, like labeled emails or house prices. In unsupervised learning, you have data without answers and want to discover patterns, like grouping customers. Semi-supervised learning uses a small number of labels with lots of unlabeled data. Reinforcement learning is about learning through trial and error by receiving rewards, like teaching a program to play a game. Deep learning is a subset of machine learning that uses large neural networks with many layers. It's especially good at images, audio, and text because it learns useful features automatically from raw data. Machine learning is not magic. It can be wrong, biased, or outdated if the data is bad or the world changes. But it matters because many problems don't have simple rules. For those problems, learning from data is the most practical solution computer science has.